Hey everybody, Vade here, and today I'm going to show you two ways to sort of prove or understand perhaps the derivative of the absolute value of x and why it is what it is. The first way I'm going to, show you how to sort of prove the derivative of the absolute value of x is, using an analytical sort of approach here, and then the next way is sort of the way I hope you guys will understand it is like graphically why it is what it is. So anyway, let's start off with the analytic way first. So we're going to say here that let's let f of x equal to the absolute value of x. And if f of x equals to the absolute value of x, doesn't f of x also equal to the square root of x squared? Because remember, the square root of x squared equals to the absolute value of x. Now, further elaboration on this is like, right, remember in Algebra 2, pre-calculus, the square root of x squared only equals x if, let me just sort of draw this here, x if x is greater than 0, or negative x, or if x is less than 0. Or, it's bad writing. If x is less than 0. So these are the two conditions here. So since we don't know if x is greater than 0 or less than 0, we have to say that the square root of x squared is just absolute value of x, because square root has to be positive still, and absolute values are positive. So with that being said here, well, let's say let's let u, right, let's let u equal to x squared here. So then we'll get the square root of u. Okay, so then f prime of x, which is our derivative, will be 1 half, right, or I can, well, let me rewrite f of x here as u to the 1 half, right, because the square root is just to the 1 half power. So then f prime of x, which is our derivative, is just 1 half u to the 1 half minus 1 times u prime. Remember our chain rule here. Now this right here is our power rule, and then this right here is our chain rule. We gotta take the derivative of the inside. So now just substitute u in for that's the wrong marker here. Substitute u in for x squared, and we get 1 half x squared to the 1 half minus 1 times 2x, okay, because u prime is the same as derivative of x squared, which is 2x. So then now we can rewrite it as 1 half times, then 1 half minus 1 is negative 1 half, so x squared to the negative 1 half times 2x. And then remember, we can write this since this is a, say, negative exponent here, we can write it as 1 half times 1 over x squared to the 1 half power times 2x. Now, if you want, we can skip ahead here and just cancel the 2's, and then we'll get 1, or we can say here, x over x squared to the 1 half. And remember, x squared to the 1 half is the same as the square root of x squared, so the square root of x squared, x over the square root of x squared. And remember that the square root of x squared, this is really the absolute value of x. So then we get x over absolute value of x is our derivative. So we can say, therefore, f prime of x equals to x over absolute value of x. So hopefully this makes sense using your previous knowledge here, like the square root of x squared, stuff like that. But this is not really the best way to understand it. I'd say that like this is analytically, like if you forget in the middle of a test, like, oh, what's the derivative of the absolute value of x, and you just can't visualize, you don't have the time to really or you just cannot visualize it at the moment. I don't know, for some weird reason, but I've been there. Use this analytical approach. This is sort of the most straightforward way of sort of getting it, but then with the way that I'm going to show you now, the visual way of seeing it, is, well, let's first graph. Why is it going to yellow? Let's first graph the absolute value of x. I think I can use like a line here. Is there like a line segment here? Okay, good. So let's say that this is the absolute value of x graph right here. Approximately, this is what the absolute value. I think I can use this line segment here as well. Let me use the line segment here. Say that this is like a. Well, we can use orange, sure. This is our absolute value of x function. Okay, this is our absolute value of x here. And so, thinking about our derivative here, well, our derivative, right, like remember this is, we can say negative infinity, this is positive infinity. As we go to the left of 0, which is negative infinity, what's happening to our slope here? Well, if we see here, this is like the line, let me sort of split between negative infinity and positive infinity. We can see here that this is actually the line y equals negative x. Now I know we don't have like graph paper here, but hopefully that makes sense. Like go on a Desmos and you can see that as well. This side of the function is like y equals negative x. And so the slope here would be just 1, right? Okay, remember that. And then of course here on the right side, approaching positive infinity, this is y equals to x, and our slope here is this is negative 1, the slope is negative 1. The slope is positive 1 here. Okay, now at 0, well, 0 is a sharp turn, right? Sharp turn. So maybe you know this already or maybe you don't. Well, but if we have the derivative of the point at which there's a cusp or a sharp turn or some sort of discontinuity, the slope is undefined. Derivative is not defined at that point. But hopefully it should make sense here. Like if there's a sharp turn at this point right here, right? I don't know what I'm gonna, like this point right here. How can we get a tangent line? Like it could be like this, like this, like this, like this. Like I don't know. So that's why the slope is undefined. So really, what the graph should look like here for the derivative is, well, we forget the straight line segments, but I'm just gonna say here. For y equals to positive x, which is to the right, well, to the right of 0, it's just going to be 1, right? And to the left of 0 here, right, with negative x, this is going to be negative 1. Let me use a marker as well. This is negative 1, or this is, no, positive 1. This is negative 1, and it should be going to the left here, right? And then here at 0, it should look something like this. There should be a hole here because it's not defined at that point. So here at x equals 0, it's undefined. The how do you say this? The derivative once graphed, when you graph the derivative. Okay, and hopefully you'll realize here that x over absolute value of x is just this, right? Plug in values to test, but this is what x over absolute value of x actually gives you. Yeah, so that's really, two ways of understanding the derivative of absolute value of x. Hopefully one way makes, sense for you, or hopefully both make sense. Use whichever way works for you, but I mean, if you forget this derivative, but I'd recommend the visual approach. It's a lot easier, I guess, to see. But analytic is also a really good way to go as well. Anyway, thanks for watching. See you in the next one.